the heat budget. It has been clear that the earth has been continuously receiving solar energy in the form of shortwave radiation, where it is converted into heat by the process of absorption, similarly through long wave terrestrial radiation, and the earth sends the same amount of energy back to the space. There exists a balance between them. In the absence of such a balance, the earth would have getting progressively warmer or colder. This balance between the amount of insolation received from the sun and outgoing terrestrial radiation is known as the heat budget. The incoming energy. The total flux of energy entering the Earth's atmosphere is estimated at 99.97%, which is equal to 174 petawatts or 340 watts per square meter. Solar radiation is about 99.997. This is equal to the product of the solar constant, about 1366 watts per square meter, and the area of the Earth's disk as seen from the sun about 1.28 into 10 to the power of 14 square meters, averaged over the Earth's surface, which is 4 times larger. Geothermal energy constitute about 0.025%. This is produced by stored heat and heat produced by radioactive decay leaking out of the Earth's interior. Tidal energy contributes about 0.02%. This is produced by the interaction of the Earth's mass with the gravitational fields of other bodies such as the moon and the sun. Waste heat from fossil fuel consumption is about 0.007%. There are other minor sources of energy that are usually ignored in these calculations. Outgoing energy. The average albedo of the earth is about 0.3, which means that 30% of the incident solar energy is reflected into space. The planet's albedo varies from months to months, but 0.3 is the average figure. It also varies very strongly spatially. Polar ice sheets have a high albedo, low at oceans. The contributions from geothermal and tidal power sources are so small that they are omitted from the following calculations. So, 30% of the incident energy is reflected, constituting of 6% reflected from the atmosphere, 20% reflected from the clouds, 4% reflected from the ground including land, water and ice, and Earth's long wave thermal radiation intensity from clouds, atmosphere and ground. The remaining 70% incident energy is absorbed, out of which 51% absorbed by the land and water, then emerging in the following ways. Out of 51, 23% transferred back into the atmosphere as latent heat by the evaporation of water called latent heat flux. 7% transmitted back into the atmosphere by heating rising air called sensible heat flux, and 6% radiated directly into the space. 15% transferred into the atmosphere by radiation, then re-radiated into the space, and 19% absorbed by the atmosphere and clouds, including 16% out of 19%, 16% re-radiated into space, 3% transferred to clouds from where it is radiated back into space. When the earth is at thermal equilibrium, the same 70% that is absorbed is re-radiated, and then 64% by the clouds and atmosphere and 6% by the ground. So, you can see it from this figure. In this way, the total incoming solar radiation is balanced by an equal amount of outgoing radiation. Number of factors can influence the intensity of the solar radiation received at the Earth's surface. We discovered that the sun can vary in its output of radiation and that a variety of geometrical relationship between Earth and the sun. They have considerable effect on the intensity of duration of incoming solar radiation. As the solar radiation passes through the Earth's atmosphere, the process of scattering, absorption, reflection can also reduce the intensity of short wave beam. The short wave energy received by the Earth's balanced by a similar quantity of long wave radiation leaving back to the space. This process is called the planetary energy balance. The generation of heat energy is strongly correlated to the quantity of short wave radiation received. The amount of insolation being received by a location on the Earth varies both spatially and temporally because of Sun-Earth geometry, Earth rotation and spatial differences in the Earth's atmospheric transparency. The spatial and temporal patterns of temperature are also influenced by factors like altitude, ocean currents and surface properties. So, in the next module, we will be discussing about the horizontal and vertical distribution of temperature.